Not all permutations are cycles, but all permutations can be expressed or written as a product of disjoint cycles. Let's consider this permutation here. We have a permutation which is an element of S8, and we have this mapping, and we are going to express this permutation as a product of disjoint cycles. Before we try and going to that, to insert a concept here, let's try to see if this permutation is really a cycle or not. So let's try to look into the sigma of 1. 1 is mapped to 8. Let's have sigma of 8. That's 1. That would mean the first orbit is 1 and then 8. Now, just a short review, we would know that a permutation is a cycle if we have at most one orbit that contains more than one element. This orbit already contains more than one element. If we could see other orbits containing more than one element, then automatically this is not a cycle. So let's have here sigma of 2. 2 is mapped to 2. That's okay. So we have this orbit containing 2 itself. If we have here sigma of 3, this is mapped to 6. Sigma of 6, we will have here 4. Sigma of 4 is 3. With this, another orbit is actually 3, 6, and 4. As you can see, we already have a second orbit that contains more than one element. So this is now enough for us to say that this permutation is not a cycle. But just for the purpose of discussion, let's just simply continue. We have sigma of 5 is 7, and sigma of 7 is also 5. So we have here again the fourth orbit, that's 5 and 7. So all of these orbits could give us the idea that this permutation is not a cycle. That's already okay. Yeah, I'm just inserting that as a part of a review. But then again, the point of this video is to determine the or give an expression as a product of disjoint cycles that will actually result to this given permutation. And the reason why we started with the idea of orbits is because we can use those orbits. Let's say orbit 1 and 8 here. Let's try to come up with a cycle using this orbit. Again, this permutation is not a cycle. We are just going to use these orbits and form independent cycles. So the first cycle that we could have is 1 and 8. Using parentheses, that would mean that it's already in a cycle. This cycle tells us that 1 is mapped to 8 and 8 is mapped to 1. All the rest of the elements, 2, 3, 4, 5, 6, and 7, are mapped into themselves. Okay? So you could express this as 1, 2, 3, 4, 5, 6, 7, 8. Only 1 is mapped to 8 and 8 is mapped to 1. That would mean here that the rest, you will have 2 is mapped to 2, 3, 4, 5, 6, 7. This is the equivalent permutation of this given cycle. Notice this is not the same as this earlier because we are just forming a cycle from this given orbit. Okay, so just not for us not to be confused, let me erase this. Okay, now let us consider this second orbit here. Since it only has one element, we cannot come up with a cycle containing that. So let's just simply leave that in the meantime. Let's consider this orbit here. The cycle that is separate from the given permutation or is actually 3, 6, and 4. And similar earlier, 3 here is mapped to 6, 6 is mapped to 4, 4 is mapped to 3, all the rest are mapped to themselves. Okay? And we have here this last orbit, you have 5 and 7. Okay? So these are now the 3 disjoint cycles, and you would know that they are disjoint because they don't share a certain element, and this when multiplied should result to the given permutation. And this is the end goal of this video. But let's just simply try to see if this will really result to our permutation and if this is really the correct answer. Okay? So let's have 1, 2, 3, 4, 5, 6, 7, and 8. So we'll have it like this. From here, because just like multiplying permutations, multiplying cycles, you do it from your right to your left. So 1 is not here, so 1 is to 1, 1 is mapped to 1, 1 is mapped to 8. Okay? Next, let's have 2. 2 is mapped to 2, 2 is mapped to 2, 2 is mapped to 2, so 2 is just mapped to 2. You would see that the first 2 already fits the given permutation. But let's just simply continue. 3 is mapped to 3, 3 is mapped to 6, 6 is mapped to 6, so 3 is mapped to 6. Okay? Then 4. 4 is mapped to 4, 4 is mapped to 3, 3 is mapped to 3, so 4 is mapped to 3. Let's have 5. 5 is mapped to 7, 7 is mapped to 7, 7 is mapped to 7, so 5 is mapped to 7. And then 6. 6 is mapped to 6, 6 is mapped to 4, 4 is mapped to 4, so you have 4 here. And then 7 is mapped to 5, 5 is mapped to 5, 5 is mapped to 5, so 7 is just simply mapped to 5. And finally, 8 is mapped to 8, 8 is mapped to 8, 8 is mapped to 1. As you can see, this permutation here is similar to the given permutation. You have 8, 2, 6, 3, 7, 4, 5, and 1. And this would mean that these 3 cycles here, 1, 8, 3, 6, 4, and 5, 7, all elements of S8, when multiplied, will result to our given permutation. And this is the end goal of this video. But then again, we started with identifying the orbits of the given permutation. Then even if it doesn't give us a cycle, or our permutation, given permutation is not a cycle, we were able to use those orbits to come up with independent and disjoint cycles that we have verified to result to our given permutation. Thank you very much for watching.